Hello class and welcome to Module 6. In this function we're going to see some more tools we can do with functions, and we're going to finally get to have an introduction to unit testing. In previous semesters unit testing was done at the beginning of the semester, but we found that students were having issues because it was too much too soon. Hopefully the way we've reworked this will make it a little bit easier. You've gotten some introduction into how Python works, and now we're going to try to layer in the unit testing. But first, some stuff about functions. So in topic 1, we're going to have a look at functions with variable parameter lists. So up until this point, we've defined functions, and we say this function takes parameter A and parameter B. And anytime you want to send anything to that function, you have to send it with exactly that many parameters for it to work. Well, we can do a little bit better than that by allowing us to vary the number of parameters we send. So as I've already said, of course, functions can have more parameters and arguments as input than what you send when you call them. This is done by setting defaults. So I'm going to do that here. So here I've got a function called getUserInfo. And all this function does is it takes the user's input and then it returns the user's input. But the thing that's different here is I have a variable called prompt. And that prompt, as you can see when I'm defining my function at the top of my window, or at the top of my function, says prompt, and then equals, tell me your first name, colon, space. What this is a default for this parameter. And the way that works is if I call this function without sending the prompt parameter, it will automatically use this as the value for that variable within the function. However, if I send that variable, it will use what I send instead. So that makes this the default, allowing me as the user of the function to override that default. So I'm going to run this to just get this green. And then in the next cell here, I'm going to call that function. And I'm going to call it a couple of different ways. You can see I've got one here saying user first name equals get user info. So the first time I call the function, I don't send that parameter. So that function is going to take on the default value for the parameter. Then I'm going to call the function a second time, but this time when I call it, you can see get user info, I'm going to send it what I want it to take on for the prompt variable. And I'm going to say, tell me your last name. And then I'm just going to print the output. So if I run this, you can see here it says, tell me your first name, because the first time I called the function, it took that default value for prompt. And then I called the function again on line 2, and it says, tell me your last name. And that's because I sent it that text this time instead of letting it take on its default value. And then now I have my output. So the nice thing here is I have a single function that I use in 2 different ways because I adjust the variable parameter the second time. So this is a perfect example. If I had a more complex function, obviously this is pretty simple, but if I have a function that is supposed to gather user input, it's supposed to make sure the input has the right variables or the right data types and the right sizes and whatnot, the right range of numbers. I could create a single function and then I can just adjust a few things, like in this case, what I'm prompting the user for, to make that function take on a separate variable or a separate setup, which is really nice because I don't have to maintain 2 functions that essentially do the same thing. I'm just slightly adjusting the one to use it in a different way. Here's a more complex example, and please focus on the part here that is important, which is that we're adjusting the parameters. But I wanted to have a kind of a more interesting example, so this is what I've done. So the first function is not as important here. It is just making sure that the inputs from the user are coming through correctly. So that's just a user input checking thing. The second function is the one I want to focus on. So you can see here it's called alarm clock setup. And it takes 4 parameters: hour wake, minute wake, buzz equals true, and AM equals true. So if I want to call this function, I have to at least send it 2 parameters because these parameters don't have default values. However, these other 2 have default values, so it's they're optional parameters to send. And all this thing does is it takes the inputs and prints out a result depending on what you set, as if it was an alarm clock. But if I step down, first it checks to see if there's an error with what I sent, and if there is, it returns a value error. As long as that's fine, then it's going to say, hey, if AM equals true, I'm going to set morning, night to AM. Otherwise, I'm going to send it to PM. And if buzz is true, I'm going to say you will be woken with a buzz. Otherwise, you'll be woken with a tone. And then it just prints the output. The alarm is set for blah, 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 blah. And then I print that it will buzz or will be a tone. So that's the function. I'll run it a bunch of different ways so you can see. I've kind of commented some of these out so I can run it in different ways. So I'm going to start with the first one. So the first time I call the function, I'm calling it with just two variables. Or two parameters. I'm calling it with my hour and my minute. So when I run the function this way, you can see the output says the alarm is set for 6:45 a.m. because that's what I sent, and it says you will be woken with a buzz. Now the important part here is by default, the AM PM is assigned to AM, and the buzz tone is set to buzz. So if I go back, these are both set to true. So that means that as I step through, buzz equals true. So that means it takes on AM, and AM equals true, so it takes on AM, and then buzz is true, so it's you will be woken with a buzz. All of that is already defaulted, so I didn't have to send those parameters. However, I can set those parameters if I want to. So on the second example here, I'm going to run it again. And this time I'm sending it all four parameters. I'm sending it the hour, the minute, AM, and buzz. And the reason I'm doing this is because I'm overriding the defaults. Now, you can see here, this is a little bit different than syntax we've seen before, where I'm saying, hey, I'm specifically saying this variable is false, and this variable is false. And the reason this is important is because if I send these out of order, then it is going to set the wrong variables. Typically, the way we do this, or we have up to this point, is when you send your parameters, it just assigns them in order that they are sent. So this would be hour, minute. If I don't remember what the third one was asking for. It's asking for buzz next, and then AM, PM. But you can see I sent them in the opposite order. So if I hadn't said use AM and buzz, it would have flipped these around and it could have taken on the wrong values. So the point here is you can say exactly what variable you're assigning to send them out of order. But if you don't want to assign the parameter value, you have to send them in order, otherwise it doesn't work. But in this case, I'm saying AM equals false, buzz equals false. So you can see it will be set for 6:55 p.m. and you'll be woken with a tone because buzz is false. On the third one, I kind of do a little bit of both here. You see I've got alarm clock setup, 7:45, and then I just say false. So what this will do is it will automatically assume that the third parameter, which is buzz, is set to false, and then AM will take on its default of true. So you can see buzz is false, so it'll be woken with a tone, and AM takes on the default value, so it becomes AM. So a lot of different functionality there. It allows us to, if you have functions where the majority of the time those variables take on a specific value, you can just pre-assign it with that default, and then most of the time it won't have to be sent to the function. However, if somebody needs to do a weird scenario or a less common scenario, they can send that parameter specifically, and that will then take on the other value. All of these libraries that we work with, the larger libraries for Python, have this kind of functionality where you don't they might have 30 different parameters that can be sent into these functions, but you really only need to send one or two, and the rest will just have a default value, so you don't have to send everything. That's what this is. We're just building it ourselves. These functions can also have multiple default parameters and arguments. That was actually out of order. Sorry, I had already done that. So you saw that I had multiple defaults. So that's what I wanted to show you with default parameters. The second topic here is called inner functions. Inner functions also take on the name nested functions, and the name makes sense, right? There are functions that are contained within another function. So encapsulation is another term you see for this. The unique thing about these kind of functions is that by encapsulating them within another function, they can only be accessed or called from the outer function. The rest of the program has no awareness and no access to the inner function. So here's an example of an inner function. So I've got my first function here called multiply number by 2, which takes a single parameter. And that function does final number equals initial number times 2, and then it returns final number. Okay, pretty straightforward. And then I've got multiplied number equals multiplied number times 2. I send it a number, return multiplied number. So I didn't define number. So hold on one moment here. Okay, that was a bit out of order. So let's run through this one. So I've got my function called get a number, which takes a number for a parameter. And then in that function, there's another function. So you can see it's tabbed in underneath. So this function contains another function. And this function is called multiply number by 2, and it takes an initial number. Okay? So final number equals initial number times 2, and then it returns final number. So the inner function returns a variable called final number. Now the outer function can call the inner function. So the outer function, you can see it's at this level. So this is part of the outer function. Can call the inner function. So you can say multiply number times 2, and it sends it the number that it just got. So the outer function takes a number and it's passing it to the inner function, which the inner function is multiplying it times 2, returning it to the outer function, and then the outer function is returning the multiplied number. Now this doesn't really make sense in this case, but it's just a simple example showing this running. And I think now if I, no, there we go. So now I'm going to call my outer function and say get a number 7. So 7 gets sent to the outer function. So number takes on the number 7, and then the outer function takes that number, passes it to the inner function, which multiplies it times 2. That 14 result gets returned to the outer function, and then the outer function returns that result. So I get 14 in the end. There you go. However, if I try to access that inner function, you can see I'm directly trying to access multiply number times 2, or number by 2, from outside of the outer function. This would be like trying to call it from main. It won't be able to find it. The reason it found it is because I did it twice here. So I apologize. That's messed this up a little bit. But anyway, I can't access, I don't know why this is here, I can't access the inner function from outside of the inner function scope, or the outer function scope. So I wouldn't be able to call the inner function directly from main, except that I did that weird cell there that messed it up. So normally this would give an error. Okay, so that's just what I want to show with inner functions. There are times where this makes sense if you have functionality that you just don't want to have accessed from the larger project scope. Really, the function itself only needs it, or it could cause confusion. You can encapsulate it and protect the rest of your program from using a function that might not have the right functionality for you. So this next part here is just a light introduction to decorators. I don't believe you have to do any assignment with this. It's just a thing that you can do that it might be worth understanding. If you see it out there, then you can generally understand what's going on. So here's an example that's pulled out of the Blackboard environment, just so I can step through it with you. You can see I've got a function, and decorators are a form of inner functions. I've got a function called a decorator, and it takes a variable called function as an input, which really it takes a function as an input. And then inside of it, there is a function called wrapper. And the wrapper function says do something before the function call. And then it runs the function that was just passed in. And then it says do something after the function call and return the wrapper. So in the end, I'm returning a function wrapped in a function. So that's what this is doing here. And then I've got my two just sample functions, a function, b function. And then down here in main, I'm calling a decorator, and I'm sending it a function, which is this one, and then assigning it to a variable. So what I'm doing here is I'm actually creating a function in a function and assigning it to a variable, and then I can call that function in a function all at once. So I end up with this say hello, and if I'm going to comment this out so you can see specifically this one. So by calling say hello, I am actually doing all three of these things. I'm doing the things from the outer function up here, and I'm doing the thing from the inner function. So I'm creating a wrapper or a decorator around this function called function. So it allows you to expand or adjust the functionality of functions by decorating them or wrapping them within other functions. I can do the same thing here with say goodbye. I'll comment this out. Nothing's really different here. It's just showing that you can do it again with the other functions. So a decorator takes B function in this case, and then I end up with this variable that is actually a function within a function that I can call. So that's I don't know if it's simple, but it's a light example of a decorator setup. I've got a couple more here that I just pulled together quick. This one here, you can see there's a function called make pretty, and then inside of it is an inner function, and in the inner function it says I got decorated, and then there's that function that got passed in from the outer function, and then it returns the inner function to the outer function, and then I've got this function called ordinary. Okay, so now there's two different ways to do this, and I show them both here. These are syntactically identical, or they result in the same thing. So I've got this is the standard way, or the more common way you'd see. I've got my ordinary function that says I am ordinary, and then I call ordinary. All right, I'm sorry, I create a variable called ordinary that has make pretty with ordinary inside of it. So I'm creating my decorated function here. And then this is the same thing, except this is just a nice view of this. So I've got a function called ordinary, and then this is a decorator type syntax for this ordinary function. So these two end up being the same thing. And if I run this, or I call ordinary now, you can see I've already output it, but it says I got decorated, I am ordinary. So I'm able to, again, decorate that inner function, I am ordinary, to do more with it. And give me expanded functionality. And that's, again, all with decorators. I just wanted you to see that it's something that exists. If you are out there and you run across it, or maybe you've used decorators in other languages, they can also be used in Python. Okay, so topic 3, introduction to unit testing. This is kind of a big thing, so I'm going to just try to step through several examples. Don't concern yourself if it doesn't all entirely make sense here, because we will be continuing to bring it in subsequent units. So this is just to get you started. And I'm going to show several examples of different types and different complexities. Again, we will continue to look at them in the following weeks. So, as I said, go over several types of unit testing, and I'll do some examples and work up some more complex situations. So, starting simple. Just in general, I want to say this, and I want to make sure you remember it, because people often have this issue. When you are doing unit testing, you are testing the functionality of your functions. Unit testing is never used to test your main part of your program. So sometimes to get proper unit testing, you have to have that thought in mind when you build your program. Because if you want to have the best testing, sometimes you have to have more functions and less in your main, because you want to be able to test that functionality within your functions. And often unit testing is simpler when you break your functions into multiple simple functions, because you test each function independently of the rest. So having one gigantic function makes testing much more complicated and much more difficult. But if you have several small functions, you can test the input-output of each one and make sure that each one works independently. So this first example, this is the code that I'm going to test. So I have a function called count the letters, and it takes an input string, and it returns the length of that string. Pretty straightforward. I'm going to just run it 3 times here so you can see how it handles these different scenarios. If I send it the text whatever, it returns 8. If I send it nothing, or an empty string, it returns 0, because that's 0 length. And then if I try to send it numbers, or a number, a integer, it doesn't know how to handle that because you can't figure out the length of an integer. So then in that case, I get a type error. So what I want to do is I want to do unit testing to ensure my function reacts the way I expect it to in each of these scenarios. So I have to exercise that function through my unit testing. So here is my unit test code. Now I'm going to show it here, and then I'm going to take it over to PyCharm so you can see how it looks in PyCharm as well, to make sure that you're comfortable with that, because I know most of you work within the PyCharm environment, and while it's similar here, I just want to make sure you can see it in both environments, but we're going to do it here first. So the first thing, import unit test, and I will show you in PyCharm how to build the structure of this automatically. When you create your unit test file, it's pretty straightforward, but I'm going to import unit test, and then I've got a class, and this part here and here is all pre-built. You can give it whatever name you want. PEP standard, it should be capital letters, no underscores for your classes. So you can see test letter counting. And then I have my test groups underneath here. Now, something that is a little tricky that throws people off is each one of these test functions needs to start with test underscore, or it will not work. So it's always lowercase test underscore. The rest, you can call it whatever you want. However, it has to start with test underscore to work correctly. Now, the good thing to do here is this part should be descriptive of what this group of tests is doing so that it makes sense to you. But really, from the program's aspect, it doesn't care. So here you can see I'm testing happy path, which means I'm testing when everything works great. And then it always has self here. And then I'm doing 3 tests here. And I'm doing assert equal. There's a whole bunch of different asserts you can do, but in this case, I'm doing assert equal, which means I want to ensure that these 2 things are equivalent. And I'm going to have first, on one side of it, I'm going to do count the letters, which means I'm calling that function, and then I'm sending it a string, just like I would call it normally. And I am ensuring that the result of this function call is the same as 24. And if it is, it passes the test. If not, it fails the test. And then I have to figure out why my program is not working as I expect it to. The second one's the same way. It's another assert equal. I'm calling the function, count the letters. I'm sending it a 0 length string, and I'm ensuring that the result of that is equivalent to 0, which we know it is. And then the third one, I'm going to send it count the letters, and this is a little bit tricky. I'm going to send it a string of numbers. So it will treat this as a string, not as the number 12,345. And then I'm going to ensure that the result of that is 5. So for all these to pass, all of these things have to be equivalent. Okay, so that's testing the happy path. I feel like that's a reasonable grouping of tests. Typically, you want more than one test because one test doesn't really tell you much about how your program is running. So I've got 3 here that are pretty decent. And then this next one, I'm doing another group of tests that is not happy path. I'm testing type error. And this is the syntax for assert raises. I want to ensure that if I send this thing bad data, it raises as I expect it to. And this sometimes seems a little bit weird because why would I want my function to ensure my function or my program fails? However, it is important because I want to know that if a user comes into my program and puts in a bad input, that my program understands that it's bad input and reacts correctly. Because if it reacts incorrectly, that bad input may continue down into my program and cause other unexpected issues. So this is actually important that that this raises an error when it's supposed to. So I'm saying with self assert raises. So this was assert equal up here. This is assert raises. Type error, I wanted to raise this specific error. So if it was you could have a value error, a type error, there's a whole host of different errors, divide by 0 error, those kind of things. But in this case, I want to ensure that a type error is raised when I do what's underneath it. So this is tabbed in, you can see. So I want to ensure that if I call the function with 2345, it will raise a type error. And if it does, this test will pass. But if it does not raise the type error, this test will fail. And then down here, this is also like boilerplate default syntax that comes along with the unit test file. If name equals main, and then it's unit test.main. This part here has to be added in for Jupyter Notebooks. You don't have to have this part in here for PyCharm. It's just a weird thing that happens with Jupyter Notebooks. So you have to have that little extra in there. And you can see it would look like this in PyCharm, unit test.main. So now if I run this, you can see I've already run it once, but if I run it again, it says ran 2 tests in whatever amount of seconds. And by 2 tests, it means 2 test groups. So 1, 2. Sometimes people will have this wrong. Like they'll have it, I'll do it here. I'm not sure if it'll happen in Jupyter Notebooks or not, but I have like test underscore, and everything looks great. But if you look closely, it says it ran 0 tests. It didn't pass anything, it just didn't test anything. And that's a problem. So you have to make sure that it says that you ran the number of test groups that you have. There you go, I got 2 tests in 0.02 seconds. Now, I'm just going to copy this code over into PyCharm so that you can see how it looks in PyCharm, because instead of just being 2 different cells, it's actually 2 different files. So I'm going to have my my program file, and I'm going to go over to, nope, that's not what I want. There we go. And I've already created my 2 files here, but I'm going to show you how I did that. I mean, you should know already how to create a program file. I just right click, go to new, and then I do Python file. We've been doing that for a while, so you should be okay there. But if I want to create a test file, I have to go again to new Python file. And then you can see here when I do unit test, I don't care, just call it hi. When I create a unit test type file, I get this boilerplate already created for me, which is really nice because then you don't have to remember all of the different little bits of syntax. It's already there for you to get started. And then you don't have to do anything here, and you don't have to do this part. You just have to do, the section where you actually put your tests in, which is really nice because then you don't have to figure out all the rest. Okay, so I've already got that over here, so I'm going to close this one. But first I want to paste in my code. So here's my code for testing. I don't know why those switched around. Here's my code for testing. I just copied over from my other program. There's one thing wrong here that I want to make sure I point out. I have my function up here, but I don't have my main section established, and that's a problem. So I need to do that. I'm going to put in my main section, and one of the beautiful things about PyCharm is that if I just type main, it will help me put in the rest, which it's the if name equals main, and then I'll just tab everything underneath it. And the reason this is important is because if I don't have my main section here, my unit tests will attempt to run the function, and then they will continue to run the main section, which is not what I want. I only want to test my functions, and I want to leave my main section alone. So and what happens often is there's something in the main section that requires user input, and then the unit test hangs up because it's waiting for a user input. The important thing about unit tests is they should always be able to run without user intervention. You shouldn't have to type anything in to get your unit test to run. If you do, something has gone wrong. Because when you build up a unit test suite of tests, whenever you add new code into your main code program repository, then you can run all your unit tests and they should all just run in the background. And that's the beauty of unit tests, is they allow you to make sure that after you make a change to your program, it doesn't break something that you created previously. So, got to have my main section. Now over to my unit test file. The thing that needs to happen here next is I have to import, I didn't have to do it in Jupyter, but here I have to import my code file to make this work. So you can see import code for testing. I don't have to do a directory here because if you look over on the left, I have them both in the same directory. But if I had them in a different directory, I would have to have the path incorrect. But in this case, they're in the same file, so I just need to say import code for testing. If I want to shorten that up, I could just say as, I don't know, CT or something like that, and then it'll take on that alias within this file. And now I can access my function from my other program within my unit tests. Otherwise, it won't be able to find that function. Okay. Now, back over to Jupyter and grab my unit test stuff right here. Copy that in place of this. Okay, no, I grabbed too much. Let me get rid of this. There we go. Okay, so these are the same tests I had over there. You saw me copy them. The thing that has to happen here that's a little bit different is it does not understand count for letters because it's going to look within its own file to find it, and it's not there. So you have to refer to your program file. So I just do CT dot. And you know things are going right when it starts trying to auto-complete it for you. So it says, oh, you're talking about this one, which I've already got. So I just have to do that for each one. CT dot. There we go. So now it knows where where that function is because I'm saying go over to the program file and access the function to use it. And I have to do the same thing down here because otherwise this won't work. Okay, now I have everything I need. If I just run this, there it goes. You can see I've got those ran 2 tests and everything's okay. Fantastic. Everything did what I expected it to. Just to show a bad case, if I sent this, something, this will not raise a type error because I'm sending it a happy path type code or happy path type variable. If I run this again, I'm going to get an error down here. You can see test failed, and then it tries to give you information. Sometimes it's a little hard to find the error, but if you keep with it, you can see assertion error, type error not raised, which means I failed to get my type error that I expected. So the lack of failure of my code is a failure of my test because I expected my program to fail in this section. So that means I need to figure out why my program is not raising a type error as it should. So that's, again, very similar to what you do in Jupyter Notebooks. It's just in 2 separate files, and some linking between the files needs to exist to be able to do this. Please don't ever send me a single file with your program in it and your unit testing in it, unless you're doing it in Jupyter Notebooks, which I'm not sure anybody is in the course. So if I'm asking for unit test, I expect to get a program file and a unit test file. Okay, continuing on, I want to show you some other unit tests because this is only the simplest case where I can just call my function with preset inputs and go. Our users don't make our lives that easy because just like everything in coding, having users makes it more difficult. So being able to take user input means for our unit tests to still be able to run automated or without user intervention, we need to mock our user inputs, and that's the module that's utilized here. So we're going to mock user inputs. I'm going to adjust to request 2 strings. Okay, so here's my code. Very similar to what I did before because I don't want the function itself to be complex here. I want us to be able to just ignore this part and work mostly on the unit test. But I've got a new function called count the letters with input. It has no inputs, but within the function it takes inputs. So I'm asking the user, give me the first string, give me the second string, and then it returns the length of the 2 strings added together. And if I run this, you can see I was already doing this before, but whatever, something, I get 17. So there are 17 characters if I combine these 2 words together. Okay, so I need to test this, right? And what we've done up to this point won't allow me to test it because I'm not taking any input parameters. I need to get my inputs from within my function itself. Okay, so we're not worrying about a type error in this case because no matter what a user inputs, Python will treat it as a string. So even if you send numbers as user input, it's going to get treated as a string by Python unless you change the type after it takes the input. So we don't have to worry about it in this case. So the first, I'm going to do this a couple of different ways. The first time, I'm going to just say anytime someone asks for input, I am going to say, pretend the user gave you this. So stepping through here, I have to also include mock in my import. So from unit test import mock. And then same thing here, same class type stuff. And then I'm creating my test. I'm calling it same input every time. And this is the syntax that you have to use. Mock.patch, built-in input, built-ins input, and then return value whatever. So this means that no matter what, if the function asks for an input, it's going to tell the function that the user input whatever. No matter what, if they ask for one input or 1,000 inputs, it's going to get whatever every time. So that means when I run this function, count the letters with input, it's going to say, give me the first number, or the first string, it'll be whatever. It says, give me the second string, it'll be whatever. And then it will add whatever and whatever together and find out it has a length of 16, which means that we can assert that this becomes 16 and is equivalent to 16. So that means that this test will pass. You can do the same thing here. It's another one where I'm saying, call it, and then this is the return value I expect. So anytime someone is asked for input, they give nothing back or hit enter right away without it putting any characters in, and I can assert that count the letters with input equals 0, because 0 plus 0 is 0. So you can see I can run these tests again, and I've got my tests working as I expect. Cool. So I was able to test with mocked input. However, there are times when we need to do a little bit more than just give the same input from the user every time, because the function expects different inputs, and we would need to be able to test those scenarios. So in this case, instead of having an unlimited number of the same user inputs over and over, we can specifically say each input that's sent. So I'm testing the same function. Again, I'm just testing it in a different way. This time I have to use mock.patch. Built-in input, and instead of using the other one, I'm using side effect. And you make sure you do side effect, not side effect. People have made that mistake before. Side effect, and then I'm using a list of values. And all this does is, the first time someone asks for, or a function asks for an input, it will get word. And the second time someone asks for input, it will get other word. The third time it asks for input, it will fail because I'm out of items. So you have to be specific. You have to have the right number of inputs, I guess, pre-established with your mocking. So this function asks for word or something, and it gets word. It asks for something else, it gets other word. Adds them together, gets 13, and this means the test will pass. This second one, the first time I say a bunch of text, and the second time I get nothing, which ends up being 12. So my tests pass. So I am very specific with the inputs each time. So if you think about a function where you're trying to test, give me your name, give me your age, give me your 3 test scores. You could establish that here using side effect. Now, the important thing is you need to wrap these in a string, even if they're numbers, because that's what happens when Python gets a regular input when you run the program, so you have to treat it the same way here. So if you get an input and you then convert it to an integer, you still have to put it as a string here and let your function convert it to an integer as if it was real input. So just something to be aware of. These should always be wrapped in quotes, because even if they're numbers or floats or whatever, they have to start out as a string. Okay, continuing on. I'm going to create a program that has multiple functions and test each of those functions. It's important to remember that unit testing doesn't test programs, it tests functions. There are times when you may need to adjust how your program is structured in order to make it testable. And I said that at the beginning, of course, because I always preempt myself. So my program is going to ask for multiple inputs, confirm that those inputs are valid, and then add those inputs to a list. Cool. Here's my program, which runs off the bottom of the screen. Let's see if I can... There's a lot here. Okay, I'm going to have to get out of this mode to be able to show it to you. Okay. So let's bring it up. Okay, so I've got this function called gather user input. It takes user input. If the user input this function then calls another function to check to see if the user input is valid. And if it gets returned fail, then it returns fail. Otherwise, it returns the integer. Okay, so these functions are relying on each other, but I've broken them out so I can test them independently. And then verify user input integer checks to see if it can convert check user input to an integer. If it gets an error, it will accept it and return fail. Otherwise, it'll return the integer version of the input. Cool. So that's two functions. And then I can do this one here. It says how many inputs. It's going to first verify user input integer. And by sending it an input, enter the number of integers you want to store. If the result is fail, returns fail, otherwise it returns the result. So all that does is takes how many inputs the user wants, and then this fourth function is get all numbers, and it takes an input of quantity, and this is basically the function where it takes it creates an empty user list. It has good input, count is 0, and then while the count is less than quantity, which is the number of numbers I want, it will assign the gather user input function to user input integer, and it'll assign the result of gather user input to integer. So basically it keeps getting numbers until it gets to the number that it wants. And if it runs into a fail scenario, it prints out you've given me a bad input, so it will be skipped. Otherwise, it will append to the list. So this is the function where I'm saying, give me my numbers, assign them to the list, and then it returns the final list. And then down here in main is where I run it. So if I run this program, let's say I want to enter 3, and I type in 7 because I'm a goon. Nope, that's not going to work. I type in 8. Nope, that's not going to work. I type in 5, and then 5, and then 5, and you can see in the end I get my list of 3 integers that are all 5. So that's how the program works. But the point I made here, I could have probably written this with less lines of code. However, I have broken things down into simple functions that I can test independently, which I'm going to do. So I have to test each of the 4 functions with various inputs to ensure they have the correct input. Now, I don't necessarily need you to test every possible test case or corner case of these things. However, you should have a reasonable cross-section of tests. When you get out into the real world, real coding, you are going to have to do pretty extensive testing because it's important to know that when you add new code to your repository that your previous code is not getting broken, and the better you unit test things, the better you can avoid that scenario where I wrote this thing 6 months ago, I changed something, I don't know why it's broken now because I didn't have a proper unit test when I wrote that thing 6 months ago. So I've got a decent cross-section here, and I've tried to group things nice. You can see test good input, and in this case I'm saying so this is test gathered user input. So this is just taking user input, and I'm saying it's going to mock that the user input 13, and then I'm going to assert that the user input becomes an integer 13. And then I'm going to do it again with 1, assert that the user input becomes the integer 1. And then here I'm going to test bad input from my gather user input function. And I'm going to try to send it whatever. And I expect that the result will be fail. And I'm going to test blank. And I'm going to assert that that result also is fail. So I've tested 2 good cases and 2 bad cases for that one function. Continuing down, this is the verify user input integer function. I'm going to test that if I send it a string, I get a result of an integer. If I send it a different string, a good string, a string of a number, I'm going to ensure that it results in an integer. And then I'm going to test bad inputs. I'm going to try to send it a string ERE and ensure that it returns fail, and then a string of nothing and ensure that it returns fail. Cool. So I've tested that one, and then I'm going to test the function how many inputs. Again, I'm going to say 13. I want to ensure that if somebody sends 13, it becomes the number 13, and then the same thing for 1. And then again, test the fail scenarios. And then this last one, the last function is the most complex. So the test is a little bit more difficult. I need to ensure that if I run the function, I do 1, 2, 3, which means get all numbers function with 3 inputs, because that's how many I expect, results in a list of 1, 2, 3. Same thing here with 8, results in 8. I'm going to send it some bad information. This is where I need to ensure that I've set up 5 mocks, even though I'm only looking for 3 numbers, because if it gets a bad input the way my function's written, it will just ask me again. So I'd say give it junk and then give it something good, give it junk, then give it something good, give it something good, and I should result in something good. Same thing here, I'm doing it with just a longer effect. And then it's got really good testing here for this function, probably maybe overboard a little bit. And you can see I've run all of my tests successfully, no problems. You sometimes get these kind of junk outputs because that it's not a problem that this happens. This doesn't require any user intervention. It's just the program outputting data as if the user was sitting there. So your input was not an integer, so you don't have to worry about that. But there should be at no point when you run these unit tests that the user is asked to input something. So if your unit test is running and it says, please insert a number, and then it sits and waits until you type something in, that's not acceptable for unit tests. The unit test should be able to run top to bottom without user actually typing anything in. Okay, that's all I wanted to show you with unit testing. Now, you don't have to do any unit testing this week. However, we'll be working with it in the coming weeks. So it's worth just reviewing this, maybe running this code, pulling it over into PyCharm and running it in a couple of files, just trying to get comfortable with it because it is something that you'll want to be able to do really from here through the rest of the semester. And it's a good skill to have because no programmer can get away with creating programs without unit testing